Alrighty, in addition to the test review, I'm going to work these two questions from the beige quiz that I had used as extra credit questions because I was afraid you'd run out of time. If you have not done these questions, then pause this video and go do them. Even if you don't have the quiz, you can write these down, but pause them, try and get them done on your own, and then I am going to work them for you. And then once I've done these two, then I'm going to go and do the review. Okay, so if you need to work these, pause them now because I'm about to do them. All right, so we are going to evaluate these. That's what the directions say. So that means I'm going to evaluate it. I've got to know what these values are. So this is 2 times, right? So the cosine of 2 pi thirds, my reference angle is pi thirds. The cosine would be 1/2. 2 pi thirds is in the second quadrant. So that is going to be a negative 1/2. Okay, minus the sine of 3 pi halves. So 3 pi halves, my unit circle is down here. So the sign would be -1. Right? So -1. So 2 times -1/2 is -1. Minus a -1 would be +1. -1 plus 1 is 0. All right, so number 10, I'm going to evaluate this. So I'm looking for the tangent of negative pi thirds. All right, so pi thirds is my reference angle. The tangent of that is the square root of 3. But this is negative pi thirds, so that's in the fourth quadrant where tangent is negative. So this is going to be a negative square root of 3 plus cosine of pi sixths. Cosine of pi sixths is the square root of 3 over 2. So this is going to give me a negative, which gives me the square root of 3 plus square root of 3 over 2. And it did say on there to do it as a single fraction. So that means I need a common denominator. So this would be 2 over 2. And that's like a 1 right there. So that's going to give me a total of 3 square roots of 3 over 2. There you go. That is you evaluating these. Don't make them harder than they are. Okay, so here is the review. Now, there's a lot going on in here. It all kind of uses the same information, but a little bit of a different way each time. So it doesn't hurt to jot little things down. Use your hand trick. I know you can't see what I'm actually doing, but as I'm going through these, I'm doing my little hand trick to make sure I have the right numbers. I mean, I know my unit circle, I understand that, but I always kind of double check myself that I'm not thinking about it wrong. And so that's why I think the video is a little bit better than just having a review worked out, because I'm trying to take you through my thought process. Like, that's the way that you need to be thinking about it and writing this stuff down. Okay, so we are graphing or sketching the inverse function. We know that sine of x looks like this. Okay, but the sine inverse actually goes from here to here, right? So you see this shape right here? That's the shape that some of you have been sketching. That is not the shape. The inverse of it, when I invert it, the shape flips around. So we know that this goes from -1 to 1 and from negative pi halves to pi halves. Well, when you do the inverse, this is your -1 and your 1, and this is your negative pi halves and your pi halves. Okay, so there's a point here, and there's a point here, but again, I'm not sketching this shape. That's the shape of sine. It goes the other way like this. So then for cosine, for cosine of x, my graph looks like this, right? And for cosine, so that we can get a positive and negative like we did here, we're going from this point to this point. That is the part that we're going to do the inverse of. So again, this is your 1 and your -1. And so that becomes what's on the x-axis here, -1 and 1. And this is 0 and pi. Not going from negative pi halves to pi halves. It's 0 and pi. So here's 0. This would be like your pi halves. Here is your pi. Okay. So at -1, right, I am up here at pi. And at 1, I'm at 0, and then I have a point right there. Now again, it's not this same shape. We have inverted it, so it doesn't come like this. It comes like this. Oops, well, make my point bigger there. There we go. All right, so for tangent of x, it looks like this. Right. And this is at negative pi halves and pi halves here. And this really goes from negative infinity to infinity. So when I invert that, oh, that's my 0. That's all I have to do. Here is my positive pi halves. Here is my negative pi halves. Okay. And then I do have a -1 and 1 that might be important here. So what's happening here at negative pi halves and pi halves is that I have asymptotes, so I still have them and they would need to be graphed. I'm still going through here at 0, right? And at 1, I'm not at pi halves. At 1, I'm actually at pi fourths and -1, negative pi fourths. So I get this point here, this point here. This is an asymptote. Oh, I knew I would miss it. Let's see if I can. Oh my goodness. Okay. There we go. Can't get my shape in there. There we go. That looks really, really bad. Okay, sorry, I got interrupted, so I'm not sure what the last thing I said was. But now I'm going to go in here and get the domain and the range. The domain and the range, that was something that was really just a hot mess on that quiz that y'all had. So if you either have the graph or at least think about the graph, or just like I did here, jot down what the graph is, even if you can just get this one. For the inverses, the domain and the range are switching places. Your domain is still your x values like they always have been. So my domain goes from -1 to 1 inclusive. My range goes from negative pi halves to pi halves. Right. Here my domain goes from -1 to 1. My range goes from 0 to pi. Domain is still x's, range is still y's. You've known that for like ever. Here in my domain, my x values go from negative infinity to infinity. And obviously that's not inclusive. My range goes from negative pi halves to pi halves. But unlike these, I'm not including it because I have asymptotes, so these are parentheses. And those are important that they're different. All right, so now I'm going to find each value or angle if possible. Okay, so that means some of them are not possible. When you're finding the inverse and its cosine, remember that you are restricted to 2 quadrants. That's why we've been drawing these circles. For cosine, you're restricted to quadrants 1 and 2 because this is your positive, this is your negative. For tangent, you are restricted to 1 and 4 because this is your positive, this is your negative. Okay, I got interrupted again, so again, don't remember the last thing I said. But you're restricted here, and remember when we do these, when your angles for cosine are always positive because in quadrant 1 and 2, they're positive. For tangent, this is a positive angle, but we would name this as a negative angle. Even though it could be a 4th quadrant angle, we've got to make sure it's just really plus or minus the reference angle. Same for sine, when you do it the inverse. Okay, positive and negative. So both of these are always just plus or minus the reference angle. Cosine is always going to be the reference angle and pi minus the reference angle. Okay. And not always 2 answers. That's not what I mean by that. I just mean that that's how you decide if it's positive or negative. All right, so Let's look at this. For the cosine inverse of negative square root of 2 over 2. Okay, so negative square root of 2 over 2, the reference angle that you would get, your alpha, is pi fourths. Okay, but it's negative, and since it's negative, we're over here in quadrant 2. And so in quadrant 2, it's pi minus the reference angle, so your answer is 3 pi fourths. That's where your answer comes from. All right, so here on number 2, tangent inverse, okay, of square root of 3 over 3, that reference angle is going to be pi sixths. So your alpha is pi sixths. But this is negative. So for negative and tangent, we're using the fourth quadrant, but I don't name it as a fourth quadrant angle. It's just plus or minus the reference angle. So since it's the negative one, it's negative pi sixths. Okay. So then arc sine. So it's the inverse, negative 1, right? So this goes from negative pi halves to pi halves, right? And when you're at negative 1 for sine, you're here at negative pi halves. Right. So now, tangent inverse of the square root of 3, right? That reference angle is pi thirds, but this is negative, so it is down in the fourth quadrant as a negative part of the reference angle. Negative pi thirds. All right, sine inverse of negative 1/2. So the 1/2, the reference angle, is pi sixths. This is negative, so it's down in the fourth quadrant. My answer is a negative pi sixths. Cosine, square root of 2 over 2 is the same as number 1. I was just looking at, it's the same thing, but that's okay. We'll talk through it again. Square root of 2 over 2, the reference angle is pi fourths. Okay, but it is cosine, so I am not in quadrants 1 and 4, I'm in quadrants 1 and 2, and so this is actually pi minus the reference angle, and that's where you get the 3 pi fourths from. Alrighty. So then I'm going to do the cosine of the cosine inverse of negative 0.8. So when you do this, sometimes these are just straight up inverses that cancel each other out, and sometimes they do not. If you can take the inverse, first I have to decide, can I take the inverse of negative 0.8? And yes, I can. Okay, and so when I do that, I will be in the second quadrant, right? And then when I take the cosine of that, I will get the negative 0.8 back. But if this is not a value I could get from taking the cosine of something, then I couldn't use it. But remember, your range for cosine, not your cosine inverse, but your range for cosine, or your domain, really, for your cosine inverse, goes from negative 1 to 1. So that falls in the negative 1 to 1, so I'm good. Since that happens, I can take those and cancel them out, and I get a negative 0.8. When I look at 8, my sine inverse of 3, my domain for my inverse is negative 1 to 1. 3 does not fall into that. I can't take the sine inverse of 3 because the highest number I could get would be a plus or would be a 1. And so this is just does not exist, or none, or something, some version of that. All right, now we had one where the cosecant we couldn't do because we couldn't take the reciprocal, but that was the cosine of 0. I'm sorry, the cosecant of 0, and I couldn't take the reciprocal of that. But I can think of my reciprocal function here. This really becomes sine cosecant, the reciprocal is cosine, so this would be, no, I'm sorry, the reciprocal is sine, duh. Reciprocal is sine. So this would be the sine inverse of 1/3. Okay, so since I can take the sine inverse of 1/3, then I take the sine inverse of 1/3 and then take the sine of it, and I get 1/3 is my answer. All right, so for number 10, since these don't match, I'm going to have to go and draw this on my circle, and I have to know which quadrant I'm going to be in. Tangent is negative in quadrant 4 and quadrant 2. But because it's the inverse, I'm always getting it out of the quadrant 4, because remember we are restricted to those 2 quadrants. So this is what my triangle is going to look like. Then tangent is opposite over adjacent, so this is 3 and 4. And then I know that this one has to be the negative. And then this is the 3, 4, 5 triangle, or I could do Pythagorean theorem if I didn't know that much. And then, so the tangent inverse gives me this angle, whatever that angle is. I don't know what it is and it doesn't matter. But then I take the sine of that angle. Sine is opposite over hypotenuse, or y over r. So I'm going to get negative 3/5. Okay, good. And you can stop me if you have questions. All right, so now I'm going to take the sine inverse of the sine of 7 pi fourths. These are different than these, where I could kind of take just take the inverse and cancel them out. It doesn't work that way. When I take the sine of 7 pi fourths, whether I know what it is or not, 7 pi fourths is almost 8 pi fourths. So I'm over here in the 4th quadrant, right? And when I get that, then I'm going to take the sine inverse of that. Sine of 7 pi fourths, that's going to be square root of 2 over 2, but it's going to be negative, right? And that doesn't even really matter, because here I am in the 4th quadrant. When I take the sine inverse of it, I have to have an angle that is in the 4th quadrant, which that one is, but I only go from negative pi halves to pi halves, so I have to name it differently. And the reference angle for 7 pi fourths is pi fourths, but it would be negative because it's always plus or minus the reference angle. Okay? All right. So then I'm going to do the tangent of the cosine inverse of 0. So this is like a 2-step one. So the cosine inverse of 0. Cosine is 0 here and here. However, I'm restricted here when I'm doing inverses, so I'm only looking at this one, right? So at pi halves, when I take the tangent, tangent is undefined there, because that's your y over your x, and you put 1 over 0, and you're going to get undefined, so this is just undefined. Okay. So when we're solving them like this, we are restricted to specific quadrants. But when we are actually solving the equation like these, we are doing it from 0 to 2 pi, all inclusive there. Okay, so I'm going to solve for cosine squared x. So this is going to give me 4 cosine squared x equals 1. So cosine squared x equals 1/4. Then I'm going to take the square root of both sides so that the cosine of x is equal to plus or minus. Always do plus or minus when you take the square root. 1/2. Okay. Then I look at which quadrant I want my answers in. So this, when it's plus and minus, I'm using all 4 quadrants. So I'm going to have 4, possibly 5 answers there, depending on what my values are. And my reference angle, so remember this is your reference angle, this is pi minus your reference angle, this is pi plus your reference angle, and then this is 2 pi minus your reference angle. Okay, so I go in here, my reference angle for cosine being 1/2 is going to be pi thirds. So pi minus pi thirds is 2 pi thirds. Pi plus pi thirds is 4 pi thirds. And then 5 pi thirds. And I get 4 answers there. Okay? Good? Mm-hmm.
It came from, because 1/2 it over, 1/2 and then...
Because from my little hand trick. 1/2, this is pi thirds.
Okay.
Okay? All right. So then here I'm going to have to factor. You can use U substitution. I saw some people doing that, so I think that is helping some people. So if I think of this as 2u squared plus 5u plus 2 equals 0, where u is equal to cosine of x. Okay. And then I can just factor that without worrying about the weird cosine stuff. So I'm going to get this. I know that this has to be 2u. This has to be 2u. No, it doesn't. I'm sorry. One of them has to be 2u, not both of them. Dang it. There you go. Then one of these is 1 and one of them is 2. And they're both going to be positive because that's positive, because we get positive, positive. So if I need them to add to 5, this one's going to have to be the 2 and this one has to be the 1 to get me the 4 and the 1. Then I can replace that and say that's 2 cosine of x plus 1 times cosine of x plus 2 equals 0. So now I get cosine of x equals negative 1/2 and cosine x equals negative 2. Okay. So to look at this one right here, cosine is negative in these two quadrants right here. So I'm going to get 2 answers from this. Here, cosine of x being negative 2, cosine of x can't be negative 2. The least it could be is negative 1, so this is an extraneous answer, doesn't even get me anything. So to get my solutions, my reference angle, once again, just like it was here, is pi thirds. So alpha is pi thirds, but that's my quadrant 1 angle, which I don't even want. I need my quadrant 2 angle, which is 2 pi thirds, and my quadrant 3 angle, which is 4 pi thirds. Okay, you good? You sure? All right. So then here, I need to solve this one. I've got cosine and sine in here, so I want to change them. It's a little bit more difficult to change just a single sign, but this cosine squared, I know I can change it to a sine squared something, so I get all sines over there. So this is going to be 2 times, I'm going to use my Pythagorean identity, and that gives me 1 minus sine squared x plus 3 sine of x equals 3. So then this is going to be 2 minus 2 sine squared x plus 3 sine x equals 3. So it's already a quadratic, so I'm going to move everything to one side. Since this is negative, I'm going to move everything over here to the right. So I'm going to make this 0 equals 2 sine squared x plus 3 sine x, no, not plus, minus 3 sine x, because I'm moving it over, not equals, oh my goodness. Then plus, I'm going to subtract that 2 over here, plus 1. Okay. So you can just factor it as it is, or you can use the u substitution. I'm just going to go ahead and factor it as it is. So this is going to give me 2 sine x and sine x. I know that if the two things have to multiply to give me 1, then it's 1 and 1, and I just got to figure out my signs. If this is positive, then the signs have to be the same. And since this is negative, it's minus, minus. So then I'll get sine x equals 1/2 and sine x equals 1. So this is where their sign is positive in the first quadrant and the second quadrant. So I'm going to get 2 answers from each one of these, possibly, except there's that one. That one's a little bit different, so maybe we don't get 2 there. So your reference angle for 1/2 for sine is pi sixths. So we get pi sixths and 5 pi sixths. Then I actually don't get 2 from here, even though there's 2 quadrants, because this is here at 1, and that is pi halves. Okay, we good? Okay. All right. So now we're going to simplify using fundamental and double angle trig identities. Now on 16, I saw a few people really struggling with how to start with this. And one of the reasons you struggle with it is because you know you got to substitute that one. But when you substitute for that, you have 3 different choices. And so a lot of people started with substituting with sine, which makes sense because there's a sign in the denominator, but then you don't get very far. But when I substitute the cosine, if you think about what they are, so cosine of 2x, oh my goodness, 2x equals 2 cosine squared x minus 1, or 1 minus 2 sine squared x, or cosine squared x minus sine squared x. And even if you get deep into a different way than the way I started, it doesn't mean you can't get yourself out of it. But if you think before you start substituting stuff in, if I substitute this one in, I'm still going to end up with two terms, even though it's a sign, because that's a positive one and a positive one. But look at what happens right here. If I take this and I replace it with this one, this is a negative one and then this positive one, and those are going to go away, and then I just have one term left. So sometimes it's better to, like if you get somewhere and you get stuck, sometimes you can get yourself out of it, but sometimes it's better just to kind of start over. So if you, by thinking through it before I start, I think I'm going to replace it with the cosine, even though there's sine in the denominator. So this is going to give me 2 cosine squared x minus 1, that's just for this part, and then plus 1 all over 2 sine squared x. So this plus 1 minus 1 goes away, so, and these 2's can cancel out once that zeroes out right there. So it leaves me with cosine squared x over sine squared x, and that gives me cotangent squared x. So on any of these simplifying, you can start them and do them a little bit differently than somebody else starts them and still get yourself in the same spot. Sometimes it just takes you more steps to get where you need to go. All right, so on 17, they're inverses, so they just cancel out and give you 1. But if you're not sure how that works, the reciprocal of cosecant is sine. So this is sine of x times the reciprocal of this. Oh, they don't cancel out and give you 1, I'm sorry. Gives me sine times the sine of x, it gives you sine squared x. They would cancel out if I was multiplying, not dividing them. But the cosecant is a reciprocal of sine. Okay. So on 18, you need to go ahead and multiply these, the difference of 2 squares. So this gives me cosecant squared x, and then minus and plus, and then minus 1. And that is just the same as, well, one of your identities that you have. I don't have the list to pop up here, but you have that the cotangent squared x plus 1 equals cosecant squared x, which means cosecant squared x minus 1 is equal to cotangent squared x. And that's your answer there. Okay, so you have to know your identities. On 19, this is your Pythagorean identity. 1 minus cosine squared is just going to give you sine squared x over the sine of x. That just gives you sine x. And, all right, then cotangent squared minus cosecant squared. Well, remember this identity right here. I know what I can replace cosecant with. So cotangent squared x minus cotangent squared x plus 1. So when I do this, got to be careful with your signs here. So cotangent squared x minus cotangent squared x, those go away. But then this is minus 1, so this gives me a negative 1. Okay, so then on 21, I would start by distributing. These are inverses, or reciprocals, so just like I was trying to say here, and I said it backwards, when I multiply them, they cancel each other out, because this is like sine squared x times 1 over sine squared x. So when I distribute that in here and that in here, this is going to give me 1 plus sine squared x times secant squared x. Okay, so secant squared x is the reciprocal of cosine, so this would be 1 plus sine squared x over cosine squared x. Then that's going to give me tangent, so 1 plus tangent squared x. And then that's one of the identities that looks very close to this, but instead of being cotangent plus 1 equals cosecant, it's tangent squared plus 1 equals secant squared. So this gives me secant squared x. All right, so on 22, I think a couple of you did kind of what I did. There's this big space here, and when I first worked it, I just worked that one part, and then went, oh dang, there's more there. But that's okay, you kind of have to work it separately anyway. anytime you have something that is above a squared, or even if it isn't, I would go ahead and try and factor that thing. So I'm going to leave the numerator, sine squared x minus cosine squared x over, and I'm going to plus this. I don't want to forget about this over here. These are reciprocals. Cotangent of x times the tangent of x just gives you 1. So there's just 1 hanging out over here. But then this is a difference of 2 squareds. So this is going to give me sine squared x minus cosine squared x times sine squared x plus cosine squared x. Dang it. Let me erase that and move that over. I shouldn't have written that yet. Okay, that plus 1 over there. So what happens here is these two things can cancel out. So now I'm left with 1 over sine squared x plus cosine squared x plus 1. Well, this is your Pythagorean identity, which is just 1. So basically you end up with 1 plus 1, which is 2. Alrighty. So for this one, I would go ahead and multiply them out. So secant x times 1 is secant x. Then minus sine x secant x. Then plus tangent x. Then minus sine x tangent x. And I'm going into this one. All right. So see if I have any. I don't have any reciprocals or anything here, but well, I mean I have reciprocals. I don't have any inverses of each other. But because I have all these secants, secant is the reciprocal of cosine. So I'm going to go ahead and change that into 1 over cosine x minus, this would be sine x over cosine x, then plus, this is tangent, so that is sine x over cosine x, minus, and then this is sine of x, and then tangent is sine over cosine, so that becomes sine squared x over cosine x. So now I have all common denominators, but these two things cancel out. So now when I combine those, I get 1 minus sine squared x over cosine of x. 1 minus sine squared x becomes cosine squared x over cosine of x. And then this cancels with one of those, and you just get cosine of x. Okay, okay with that? All right. So now, do this one here. So 2 times the cosine of x over sine of 2x. So 2 cosine x over, I only have one choice for this double angle. So that's 2 sine x cosine x. So the 2's cancel out, the cosines cancel out. I'm left with 1 over sine of x, which is cosecant x. All right. So here, I know that I can just go ahead and distribute, or I can go ahead and replace some things here. I know that secant is 1 over cosine, so I could change this to cosine, or I could change this, I could use my Pythagorean identity to change that to cosine something, or I could do that as 1 over cosine, or I could go ahead and distribute. Okay, so the way I did it is I went ahead and distributed. So I'm going to get secant squared x times sine squared x minus secant squared x. Then I did my reciprocals, so I got sine squared x over cosine squared x minus 1 over cosine squared x. I think you end up doing the same steps, you just may be doing them in a different order. And so once I did that, I thought, you know what, I think that I probably might have wanted to leave it as the secant, because sine squared over cosine squared gives me tangent, and then I know tangent and secant go together, so I'm going to fix it. So sometimes I wanted you to see that sometimes you change it and you go, you know what, I think I liked it better that way. Or you can continue it this way. There's ways to substitute it in and you still get to where you need to be. But sine squared x over cosine squared x is actually tangent squared x. So if I do tangent squared x minus secant squared x, then I can substitute something in there. And I know that I have this as the cotangent and cosecant, but this is the same relationship for tangent and secant. So if I substitute the secant in there, I know that I'm going to have tangent squared x minus, and then that's tangent squared x plus 1. So tangent squared minus tangent squared, those cancel out, and then minus 1 gives me the negative 1. Okay, but definitely different ways to go about some of these and get to where you need to be. All right, so let's look at 26. So I'm going to change the tangent to sine over cosine. So that'll give me sine squared x over cosine x plus 1 over secant is going to give me cosine of x. But I would like to get a common denominator here, so if I multiply this by cosine over cosine, that's going to give me cosine squared over cosine. So now I have a common denominator, and I get sine squared x plus cosine squared x all over cosine of x. So sine squared plus cosine squared is 1. That gives me 1 over cosine, which is secant of x. Good? All right, so 27. I would start by getting a common denominator. So that's going to change this 1 to cosecant of x, like this. Let's see, I don't have a whole lot of room. So I'm going to change this to cosecant x plus 1 over cosecant x plus 1. That way I can get a common denominator, and then I'm going to add it to all of this here. So this gives me cosecant x, not to the x power, dang it, cosecant x plus 1 plus cotangent squared x all over cosecant x plus 1. Right. And then I'm going to change that cotangent x to be, the cotangent squared rather, to be 1, or to be cosecant squared minus 1, because that comes from this right here. Cotangent would be cosecant squared minus 1. And I may need to go down into here. So this gives me cosecant x plus 1 plus cosecant squared x minus 1 all over cosecant x plus 1. So these 1's here cancel out. That's a plus 1 and a minus 1. So then I'm left with this cosecant x plus cosecant squared x, and I'm going to factor out a cosecant. So cosecant x times 1 plus cosecant x all over cosecant x plus 1. So those cancel out, and I'm just left with cosecant of x. Okay. So the next one. I'm going to change the tangent squared to sine squared over, actually, change it to cotangent squared, so it'll be cosine squared over sine squared. So this will give me secant of x minus cosine of x times cosine squared x over sine squared x. So when I distribute this right here. This is going to give me secant x times the cosine squared x minus cosine cubed x all over sine squared x. So secant and cosine are reciprocals of each other, so I can cancel that with one of those. And then I can factor out a cosine. So this is going to give me cosine of x times 1 minus cosine squared x all over sine squared x. So then 1 minus cosine is sine squared. So this gives me cosine of x times sine squared x all over sine squared x. So those cancel out, and I'm left with cosine of x. And those are fun little math puzzles. You okay with that? All right, so now it says to evaluate each expression using the given trig ratio, and it tells you we're in it's a quadrant 3 angle. Okay, so I'm going to draw my little picture here. Quadrant 3 angle. And it's sine, so this is my angle, and that's opposite over hypotenuse. This is negative. Now, I saw a couple of people have the wrong value for x here because they didn't do Pythagorean theorem correctly. So make sure you're doing Pythagorean theorem correctly. It's going to be 9 minus 4, which is 5. So this is the square root of 5. And on top of that, here's where some of you messed up on the homework. That is a negative 5 because I am in the second quadrant there. So I'm sorry, negative square root of 5. And then I would suggest, before you even start, you have sine theta right here. I'm going to go ahead and write out what cosine theta is and what tangent theta is so that I have it before I do anything else. So my cosine is negative square root of 5 over 3. And then my tangent, they're both negative, so it's going to be positive. It's the 2 over the square root of 5. And I'd have to rationalize my denominator, so it's 2 square root of 5 over 5. So that way I already have the values that I need when I go substitute them in. All right, so cosine of 2 theta. You can decide whichever one you want to use. There's 3 versions, and I wrote them up there at the top, and you should have your double angles. So that you don't forget if there's a 2 or a 1 or whatever. I just kind of default always do cosine squared theta minus sine squared theta. That way I don't mess up if it's plus or minus and which one has the 2 and that sort of thing. Because I got to square them and that's not that big a deal anyway. I know what cosine squared theta, or what cosine theta is. It's negative square root of 5 over 3 squared minus sine, which is negative 2 thirds squared. So here are the things that I've seen, bad things, is that I know you know how to square things, but when you square them, they become positive. Okay, so both of those will end up being positive, but there's still a minus there. And you got to actually square it, meaning multiply the denominator too. So when I square the square root of 5, negative square root of 5 over 3, I know it's going to be positive. Square root of 5 becomes 5, 3 becomes a 9, minus, this becomes positive, and that's going to be 4/9. So when I subtract those, I get 1/9. All right, so then the sine of 2 theta, that becomes 2 sine theta cosine theta. So this is going to be 2 times sine that they gave me, negative 2/3, times cosine, which is negative square root of 5 over 3. Watch your signs because most people are just making sign errors or ridiculous multiplication errors. So in the end, this whole thing's positive because I got negative times a negative. So this is like over 1. 2 times 2 is 4, so this is 4 square root of 5 over 9. And then for tangent of 2 theta becomes 2 tangent theta over 1 minus tangent squared theta. Okay, so this is going to be 2 times 2 square root of 5 over 5 over 1 minus 2 square root of 5 over 5 squared. So this 2 goes over 1. So my numerator becomes 4 square root of 5 over 5 over 1 minus. So when I square this, square the 2 and get 4, square the square root of 5 and get 5. So this gives me 20 over 5. So this becomes 4 square root of 5 over 5 over, that would be like 25, or it would be 5 over 5. What did I do wrong? Oh, it's 20. Oh, 20 over 25. Dang it, I did what I told y'all not to do. I got to square the 5 also and get 25 down there. I knew I was supposed to have a 25. I was confused. So this is going to be 25 over 25 minus that, so that's going to give you 5 over 25. So this reduces down to 1/5. Then I'm dividing fractions, so I'm going to flip and multiply. 4 square root of 5 over 5 times 5 over 1. Those cancel out, and I get 4 square root of 5. Make sure you square the denominator too, just like I said. Like my daddy always said, do as I say, not as I do. All right, then we're going to evaluate each expression. I did these in class, but I'm going to do them again anyway because I erased it. All right, so we're evaluating, meaning I'm changing these to values. So this is going to be 4 cosine of 2 pi thirds. So my reference angle is pi thirds. And so my cosine is 1/2, but that's in the second quadrant. So this is a negative 1/2. Minus 2 times the tangent of 5 pi fourths. So my reference angle is pi fourths, and that is a, that's 1. But then I'm in the third quadrant, and in the third quadrant, tangent is positive, so it's just 1. So minus 2 times 1. So 4 times a negative 1/2 is a negative 2. Minus 2 gives me a negative 4. Okay. And then here, sine of pi thirds, that's going to be square root of 3 over 2. Tangent of pi sixths, that's going to be square root of 3 over 3. Minus tangent of pi thirds is square root of 3. And then you can distribute if you want. I would combine before I distribute. So in order for me to distribute, I need to get a common denominator. And so my common denominator would be 3. So this would become 3 over 3 right there. So then that gives me square root of 3 over 2 times 1 square root of 3 minus 3 square root of 3 is negative 2 square root of 3 over 3. When you multiply fractions, you multiply straight across. So square root of 3 times the square root of 3 is 3. Times 2, that's a negative 6 over 6, which is negative 1. Okay. Everybody good with that? Any questions? No? Okay. All right, so you have to know your values around the circle, know your hand trick, use that often, think about your quadrants, and you can do very well on this.